this is Chris Abram from Nano. We're a small business based in New Jersey, and we want to share with you our battery cathode manufacturing technologies with a view to developing fruitful partnerships to scale up these technologies in the United States. So we began in Princeton University in 2017, and our mission is to develop environmentally friendly manufacturing solutions for high performance energy storage materials for electric vehicles. So we've three relevant patents on the technologies I'll be talking about. We receive funding from the Department of Energy and actively collaborate with academic and industry partners in the materials, batteries and electric vehicles area. So we are providing solutions for the next generation of cathode manufacturing. So the co-precipitation route is the prevailing cathode production technology and is dominated by countries such as China, Korea and Japan at present. So in this process, metals are processed into metal salts, which is itself an energy-intensive process. Sulfate salts are then fed into the co-precipitation reactor, which requires additional chemicals and generates wastewater, which requires energy-intensive processing for recovery. So in other words, this is a time-consuming, capital-intensive and environmentally damaging process that needs to be updated. We have two technologies which are completely different. First, we're working on an aerosol synthesis process. It forms a lithiated active cathode material with low energy and no additional chemicals in a rapid process step. Second, we're working on a direct metal oxidation to cathode process. This process completely eliminates the conversion of metal to metal salts, which further reduces the time, the environmental impact and the cost of the cathode material significantly. Turning to the first of these technologies, the aerosol method is very flexible for designing novel materials with precise ion doping. So as shown, we can achieve selective ion precipitation, which forms a concentration gradient structure. This improves the thermal stability and the electrochemical performance of the material. Moreover, this method has a very broad compositional flexibility, is fast, and it requires no additional chemicals. In the second method we're working on, direct metal oxidation to cathode. From a manufacturing standpoint, this method is truly single step. It completely eliminates two major steps in co-precipitation by working directly with metals, and it's fully compatible with existing plants, so it makes scale up very straightforward. So we can use this method to produce gradient structure, high performance, cobalt free and nickel rich materials. In summary, these are two technologies which have the potential to transform conventional cathode manufacturing, and we are looking for partnerships to commercialize these technologies and establish environmentally cathode manufacturing here in the United States. Thank you.
I'm Bob Backrack, co-founder and senior vice president of eJoule Incorporated. eJoule is a California company with world headquarters in R&D center in Fremont, California. The pilot facility with 200 metric ton capability is in Hsinchu, Taiwan, and the first 1,500 metric ton production plant is in China. Today I'm submitting comment for Area 7, advocating investment in high volume lithium-ion cathode active material U.S. production as part of the proposed FOA 2678 in support of the bipartisan infrastructure law, battery materials processing and battery manufacturing funding. High volume is defined by supportive of typical vehicle OEM production targets of 500,000 EV per year or 50,000 metric tons. eJoule has developed disruptive, scalable synthesis process flow for high volume manufacturing of lithium-ion cathode active material. The eJoule process flow goes directly from solution of all the chemical components to crystalline cathode powder. Comparison with the Argonne National Lab analysis of the incumbent hydrothermal precursor CAM, calcination to CAM process flow finds the eJoule process is cost competitive while yielding high performance cathode powder. The eJoule expected burden product production process cost is estimated to be 10 to 15% below the published figures. The eJoule process is particularly suited to incorporating dopants directly into the solution, which are essential to achieving high energy, low to no cobalt compositions. eJoule process flow is based on proprietary equipment and chemistry developed in the United States which produces high-performance, price-competitive cathode active material. The high-throughput unit equipment module is compact, energy and water efficient, and configured for zero emission. Because the plant minimum economic unit is 500 metric tons per year, an eJoule plant can be built in sections which can produce customer-specific compositions. eJoule equipment can be dry cleaned and composition changed in a matter of days. eJoule has done a conceptual design study of a 50,000 metric ton CAM plant which can be built in any suitable location in the United States with joint venture or DOE teaming partners. eJoule strongly advocates DOE including funding for CAM production as part of the FOA 2678. CAM production is essential to establishing the lithium-ion battery supply chain. I appreciate the opportunity to make these comments and look forward to
Hi, this is Mark Gresser, CEO of Wildcat Discovery Technologies. Today I'll be talking about our technology, our plan for U.S. manufacture, and some of the challenges we're facing. Our company was founded in 2007. We've built a unique high-throughput platform for the research and discovery of new materials for the battery industry. We've been doing this and working with companies throughout the supply chain for over 10 years now. And in the past 3 or 4 years, we've been working on new material technologies for ourselves, and we plan to take these to the market by 2024. The 3 big internal targets we're working on are the Wildcat cathode, a high-energy cathode that contains low-cost materials, contains no nickel, no cobalt, and has the potential to be 56% more energetic than today's best cathodes. We're also working on a solid-state electrolyte, and we're also working on lithium metal protection strategies. Our plan is to manufacture both the cathode material and our solid-state electrolyte materials in-house here in the United States. That puts us sort of dead center in the supply chain shown here. Some of the challenges we face. Significant capital is required to make this plan a reality. We've raised quite a lot ourselves. We're hoping to get some grant money and some additional funding in the coming 2 years as we scale up and show that our technologies are ready for commercialization. We think it's important that the DOE invest not just in the manufacturing, but also in R&D and product development, which must go hand in hand with the manufacturing to ensure U.S. supply chain sustainability. We're having difficulty hiring people for various roles in our space. Very few scientists have work authorization for the US. Our government could make that easier, at least as a short-term solution. We'd like the DOE and our government to provide more funding for STEM opportunities, especially early in grade school in particular, we think would be very, very useful. And we also think that scientists should be encouraged to do PhDs in very practical technologies, battery chemistries, and technologies that the industry is using today, not far out materials or ideas that could happen in 10 or 15 years, because we just aren't finding people with relevant experience. These are our recommendations. This is a summary of our company. We thank you for your time.
Hi, my name is Vivas Kumar and I am the CEO and co-founder of Mitra Chem. We are an American lithium-ion battery materials product company focused on solving 3 problems. Number 1, reducing the design build test cycle to bring a new cathode product to market from 18 months down to 1 month or less. We accomplish this goal by leveraging an in-house machine learning advantage built on the same principles of research from our co-founder and Stanford professor, William Chu. The second is to work on iron-based cathodes, which reduce our dependence on nickel and cobalt specialty chemicals materials based on a supply chain that is mostly in China today. And finally, industrializing these cathodes in purpose-built facilities for large-scale manufacturing right here in the United States. Today, we are constructing our lab in Mountain View, California, which is where we will be able to accomplish all aspects of design, building, and testing, all the way up to 10 kilogram batch runs by the end of the year 2022. And by the end of 2022, we will also be able to prove a 1-month design build test cycle to get towards new iron-based cathode products that meets customer specifications. Our plan then is to build and co-locate pilot scale capacity to show industrialization potential by the end of 2023, and then ultimately work with an American customer to build a large-scale facility to fit within a vertically integrated supply chain hub right here in the United States. There are 2 problems and there are 2 ways that we're thinking about this large-scale manufacturing. So the first is jobs. Job creation will be for specialty chemical talent, which inherently has a high economic multiplier. There are already many regions within the United States that has this kind of talent that we could target in terms of our expansion. The second is in the cost of energy and the proliferation of increased renewables. Over 50% of the cost of manufacturing iron-based cathodes is in the consumption of electricity. And if we could pair our facility with a region that has large and growing renewables penetration, or with a government mandate for increasing renewables for industrial applications, we can bring down the cost of our product to be more competitive with those of made in China cathodes. Considering that the United States has almost 0 capacity for commercial scale production of cathodes, we would like to be at the forefront of solving this problem. We would like to thank NatBat, Liebridge, Argonne, and the Department of Energy for this opportunity, and we look forward to working with you and multiple other players to build the American battery supply chain.
Hi everyone, this is Shane Thompson, the president of Retriev Technologies. Retriev Technologies is one of the oldest and largest lithium-ion recyclers in North America. Our facilities are in Trail, British Columbia, and in Lancaster, Ohio. That facility in Ohio was actually co-funded with money from the Department of Energy to fund the recycling of lithium-ion batteries. Where we currently are, or we're producing a material called a black mass, where the nickel and cobalt are recovered. But those materials, generally speaking, don't make their way back into the battery supply chain. From a technology standpoint, we understand that this is the critical ingredient in a domestic supply chain for the production of batteries is the availability of supply. So what we're doing is we're currently walking down a technology pathway where we'll introduce more hydrometallurgy on site. That will be happening this year. That will allow us to both process more lithium ion, but also to create a more preferable material, an upgraded material. Ultimately, our goal is to get all the way to new cathode production. We've talked about this in a joint development agreement with 6K Energy. They have a process for making cathode that we think is potentially very disruptive. So for us, operating a TSDF Part B facility, so we operate a fully permitted environmental facility. We understand the collection and transportation. We've got some very interesting synergies with our partner companies, Heritage Crystal Clean, Heritage Environmental Services. We recently acquired Battery Solutions. All of these create logistical advantages. We see eventually the numbers getting so large that regional processing will start to become a more and more important part of the long-term battery recycling equation. So from a technology standpoint, we definitely, funds that would help growth would be a welcome addition. We're also looking at testing capabilities to kind of rapidly assess the state of health of batteries so we can determine which batteries go for recycling and which batteries can be used for second life. So we're making some investments in what we call 2L or second life and finding applications where the batteries may be better suited as energy storage devices. And then we're working down the path on the technology side to make sure that ultimately the material gets back to new cathode. So we're looking forward to that endeavor and happy to talk more about specifically what we're doing there in Ohio and Southern California. Thank you.
Hello, my name is Sam Tretch, and I'm the president of 6K Energy. We are all aware that there is zero battery material production in the United States, and as we invest aggressively to address this, 6K believes that if we invest solely in today's technology, it is ultimately not a long-term sustainable solution. We believe that we must invest in transformational technology to ensure that battery material production and the associated jobs do not ultimately flow back to China, thus idling major capital investments. 6K is based on a technology derived from the MIT Plasma Science and Fusion Center. The company now has over 120 employees and is raising $150 million, of which a significant portion will go towards deploying our US-based manufacturing plants. We have 126 patents, which cover the equipment all the way through the processing of the material on the equipment. We are currently installing systems in our pilot facility outside of Boston, which will have the capability to provide enough powder to support 400 megawatt hours. So how do we do this? If you look at the far left flow chart, that is an example of today's process known as co-precipitation, which is a multi-step, multi-day process. If you look at the 6K flow chart, our technology is a three-step process that uses 10% of the water. It uses a third of the energy and it creates zero solid or liquid waste and essentially completes in 3 hours. So we collapse a 3-day process that is very energy, water, and waste intensive to a 3-hour clean process. By doing that, if you look at the chart on the right, we save multiple dollars per kilogram versus China on the conversion into battery materials. And we believe that it's this type of technology that is needed for a long-term sustainable industry. If you apply the savings to the 400 gigawatt hours of stated lithium ion production in 2025 in the United States, and you run that for 5 years, essentially 2 terawatt hours worth of energy, you would realize a $10 billion savings from the processing of those materials. That savings is realized by eliminating the need to deal with 340 billion liters of waste, eliminating the need to use 300 billion liters of water, and eliminating 70% of the energy that's needed to make those materials, thus eliminating 30 million tons of equivalent CO2 emissions. A few points on this slide. Our commercial scale plant will require about half the land and half the plant square footage. This gives us a lot of optionality when selecting locations. Secondly, the technology is very modular, so you can start up and run as you're scaling. And lastly, the CapEx isn't tied to just one chemistry. Within 1 day, the same machine can go between running NMC 811 and then convert to LFP. So in conclusion, as the lithium-ion ecosystem grows in the United States, we must act now and invest in leapfrog technology to establish a long-term sustainable industry. 6K is positioned to be a leader in the battery materials manufacturing space and leverage the upcoming grant funds to deploy multiple plants supporting multiple chemistries and upcycling recycled content for our partners. With that, on behalf of everyone at 6K, thank you for this opportunity to share our story.
Hello, and welcome to the Bridging the Gap workshop. Umicore thanks the Department of Energy for this opportunity to present. Let's start with a bit about who we are. Umicore is a global materials technology and recycling group. We are known for three main things. First, we are one of the global leaders in automotive emission control catalysts and have been a tier supplier to the automotive industry for more than 3 decades. Second, we are a leading global supplier of rechargeable battery materials for electric vehicles and portable electronics. And third, Umicore is the world's leading recycler of complex waste streams. We recycle the end-of-life catalysts and battery materials we make, as well as other complex materials. Umicore is a global leader in producing cathode active materials, a key component influencing the performance and cost of lithium-ion batteries. We started in this market over 20 years ago and now have 8 production sites worldwide. This year, Umicore will produce enough cathode material to power 1 million vehicles. Umicore has a global battery production footprint with cathode manufacturing in Korea, China, and soon in Poland. Our raw material refining and precursor production facilities make Umicore unique. We can supply our customers with cathode material that is completely independent of China. Umicore is also evaluating growing our operations into North America in order to be closer to our customers. Umicore has built Europe's first cathode material production in Nysa, Poland, and commercial scale production will start in mid-2022. This site is fueled by 100% wind energy, and any future expansion across the globe will also need to be powered by green electricity. Recycling end-of-life batteries is one way to help meet the rapidly growing demand for sustainably sourced raw materials. Umicore's unique processes allow us to recycle batteries in the most sustainable way. We recover lithium, cobalt, nickel, copper, and other metals from production scrap and end-of-life batteries. Umicore is active throughout the battery materials supply chain, and we ensure strict sustainability and ethical sourcing requirements for all our materials. Umicore's businesses also provide that end-of-life batteries are recycled and their contents returned to the supply chain. From cathode production to battery recycling, Umicore closes the loop from mine to wheel, which is crucial to the creation of a circular economy for batteries. Thank you for your time, and if you have any questions, please reach out to Rob Prevet or Casey Westhoff using the coordinates on your screen.
Hello and welcome. My name is Dr. Paul Everill, and I'm the Chief Technology Officer for Black Diamond Structures, where we build nanomaterials for the United States of America. We're currently under site selection processes for our next manufacturing facility, which will include thousands of metric tons of manufacturing capability for these essential energy storage materials. Our technology advances North American battery supply chains by providing the tools that the manufacturers need to make the next generation of world-class batteries. Our products are vital components to any high-rate, energy-dense cell in the market today and in the markets to come. Our anode products provide higher energy density by enabling silicon graphite anodes, where our cathode products enable high-rate capabilities by removing large concentrations of inactive material and replacing them with fractional percentages of our discrete carbon nanotube solutions. Our company is charged with fulfilling a huge unmet need in the North American marketplace, and that is the complete lack or near complete lack of large-scale nanomaterial manufacture. The world's best cells are enabled by nanomaterials, and yet North America has zero capability to manufacture them on the scale required to service the gigawatt factories that are on their way. This makes us dependent on external sources of nanomaterials, such as the Chinese, the Russians, and the Koreans, which slows our transition to energy independence. The facility in Austin, Texas that we have operational today provides 100 metric tons capacity per annum, That is enough to supply about 40 gigawatt hours of cells. Our next facility will provide 10 times this amount, enough to feed the hundreds of gigawatt hours coming online in the coming years. We plan to design a factory and a facility to bring carbon nanotube synthesis, purification, and formulation directly into one location and make that very close to cell manufacturers or points of cell manufacture. Brownfield sites could include Houston, Texas, and Jeffersonville, Indiana. Other locations are being scouted, of course, dependent on existing infrastructure and the access to skilled labor in the facility. If you would like to learn more about our products, our plans for scale up, and our future in the North American supply chain, please reach out and contact me as soon as possible. Thank you. Goodbye.